Good morning, good afternoon, good evening. This is Mr. Payne bringing you Zero Product Laws Continued. Objective today, students will be able to identify the roots algebraically. The zero product law's importance to mathematics cannot be overstated. It finally allows us, in certain situations, to solve equations that are higher order polynomials than just linear. Of course, for it to work, we must have two coordinates meet. One, we must have the equation set equal to 0, and 2, we must be able to factor the expression equal to 0. Solve each of the following equations using factoring. Like I said, this lesson is a quick review of what we did the night before. So A, notice that it is a trinomial with the A that equals 1. So I can go ahead and do two parentheses and make sure that it's set equal to 0. X and X. Copycat my first sign, so it's plus. The second sign tells me that it's different, so I should have a plus and a minus. I then ask myself, what times what gives me 35 subtracts to give me 2? You should tell me 7 and 5. The next step that I'm going to do is I'm going to tee it up. And I'm going to set each side equal to 0. X plus 7 equals 0. X minus 5 equals 0. Subtract 7 on both sides. X equals negative 7. Add 5 on both sides. X equals 5. B, the first thing when we look at a trinomial is that we should see if there's a GCF, especially when there's an A greater than 1. Is there a GCF between 3, 30, and 48? The answer to that is yes. My GCF is 3. So I divide by 3. I put 3 out in front of my parentheses. I'm left with x squared minus 10x plus 16, which equals 0. I then have to notice that inside my parentheses is still a trinomial with an x squared. So that means I can continue to factor. I'm going to bring down my 3, two parentheses, keep it equal to 0, x and x, copy my first sign, which is minus. The second sign tells me that they're going to be the same, so it should be minus minus. What times what gives me 16 adds to give me 10. Well, by now you should be telling me 8 and 2. With this problem, don't forget from the night before that I should be factoring it the zeros 3 times. I should have 3 t-bars, or 2 t-bars. 3 equals 0. I can go ahead and get my red marker out, put an X through that, and hit reject. That cannot be true. The next one, x minus 8 equals 0. Add 8 to both sides. X will equal 8. So there's one root. And then I'm going to have x minus 2 equals 0. Add 2 to both sides. X equals 2. And there's my second root. Those are my roots. Let's look at problem C now. What we need to notice from earlier in the year is that I have x minus 3 and x minus 3 that are exactly the same. So I'm going to pull those out. So I have x minus 3. And then what do I have left? I have x plus 1 plus 2x minus 7. In these next few lessons, we have to utilize the skills that we've learned throughout the year to solve these and simplify these type of equations. So this x minus 3 we're just going to hold on to for a second. I'm going to simplify the right hand side where I can. I have x plus 2x, which gives me 3x. And then I have 1 minus 7, which gives me a negative 6. Now all I have to do from this point on is tee it up. They're already factored and simplified, so just go ahead and tee it up and make sure that it's set equal to 0. So x minus 3 equals 0, 3x minus 6 equals 0. Add 3 on both sides. X equals 3. On the right hand side, add 6. 3x equals 6. Divide by 3. X will equal 2. So I have two roots. X equals 3 and x equals 2. We can even explore higher order polynomials and their zeros on a very limited basis. So far, the best we have done in x squared, but polynomials that contain an x cubed can also be analyzed. These are also known as cubics. Consider the cubic function f of x equals x cubed minus 9x. Find the zeros of this function algebraically. On an exam, what that means is you have to factor it and tee it up. So I'm going to rewrite the problem and let's factor it. I notice that I have a GCF of x. So I'm going to pull out x, pull out x. I'm going to have x out front, parenthesis, parenthesis. I'm left with x minus 9, or x squared minus 9 equals 0. Well, now I also see that I have a DOPS problem inside. I have perfect squared with the minus sign. So I can go ahead now and do 2 parentheses equals 0. X minus 3, x plus 3. The next step is to go ahead and tee it up. X equals 0, x minus 3 equals 0, and x plus 3 equals 0. This guy is good. One root is x equals 0. I'm going to add 3 on both sides. X equals positive 3. And then subtract 3 on both sides. X equals negative 3. These are my 3 roots. I have x equals 0, x equals 3, and x equals negative 3. Now what I want you to do is use your calculator. So I already have it done for us. I want you to type in your calculator x caret 3 minus 9x. Now I would like you to go ahead and hit graph. And this is what it should look like. Inside my graph, you should notice it crosses at negative 3, negative 3, 0, and positive 3. If I were to go ahead and sketch it, it would look like something like this. If you have any questions, feel free to see us tomorrow and ask those questions tomorrow. What I would like you to do right now on your own is exercise number 4, A and B. So once again, I would like you to do exercise 4, A and B for class. That is what we're checking. Make sure you have those done so you can get full credit on your homework.